Right now, beneath your feet, a war is being fought. Not for land, not for oil, for something far more precious. While the world watches stock markets and energy prices, a far more critical resource is being drained in near total silence. The ancient water locked beneath the earth for thousands of years.
We call them aquifers, vast underground reservoirs that have been the quiet foundation of human civilization for centuries. But a landmark series of NASA satellite studies has revealed the shocking truth: we are emptying them faster than nature can ever refill them. In 2015, scientists analyzed data from NASA's GRACE satellite mission and published their findings in Nature Climate Change. Their conclusion: 21 of the world's 37 largest aquifer systems were being depleted faster than they were being naturally recharged. Many showed no meaningful sign of recharge at all. Since then, the rate of extraction has only increased. For most of human history, what lay underground was invisible. Farmers dug wells and hoped. Nations had no means of knowing how much their neighbors were drawing from a shared underground pool. Then came NASA's GRACE mission, the Gravity Recovery in Climate Experiment, launched in 2002, and its successor, GRACE-FO, in 2018. These satellites don't take photographs, they measure something far more subtle: tiny shifts in Earth's gravitational field caused by changes in mass. When groundwater disappears, the land becomes fractionally lighter, and the satellites feel it. The implications are profound. For the first time, nations possess something close to X-ray vision into underground reserves, including reserves that cross borders. In regions like the Middle East and South Asia, this knowledge has intensified a dangerous race to pump. If your neighbor is drawing from the same underground system, the rational response is to extract faster and drill deeper before there is nothing left to claim. Much of the water being extracted today is not groundwater in any conventional sense. It is fossil water, ancient reserves that accumulated during the last ice age, some of it between 10,000 and 30,000 years old. Water that has never seen sunlight in the entire history of human civilization. The Ogallala Aquifer, stretching beneath the American Great Plains, supplies roughly 30% of all groundwater used for irrigation across the United States. It took over 1 million years to fill. At current extraction rates, significant portions of the southern Ogallala are projected to be functionally depleted within decades, not centuries. In Saudi Arabia, the kingdom built much of its agricultural ambition on deep, non-renewable fossil aquifers. The water was real, the harvests were real, but so was the depletion. By 2016, Saudi Arabia had formally phased out domestic wheat production, an acknowledgement that the ancient water powering those crops was essentially gone and could never be replaced. When we drain an aquifer, the ground above it doesn't stay still, it collapses. This is land subsidence, and it is happening on every inhabited continent. The markers on that pole are real. They were placed and documented by USGS geologist Joseph Poland, and they record decades of the Earth quietly caving in beneath California's Central Valley as water was pumped out below. In Jakarta, Indonesia, parts of the city sank by as much as 25 centimeters in a single year, largely driven by decades of groundwater extraction. The subsidence grew so severe that it became one of the critical factors behind Indonesia's decision to relocate its national capital entirely. But the most irreversible consequence of subsidence is this. When the clay layers within an aquifer compact under the weight of the soil above them, the microscopic pores that once held water are permanently crushed. Even if rainfall returned in extraordinary abundance, the storage capacity is gone forever. The aquifer structure simply cannot hold what nature might try to give back. There are over 300 transboundary aquifer systems worldwide, underground water bodies that flow silently beneath international borders. According to UNESCO, the vast majority of them have no binding legal framework for shared management. They are shared commons with no rules. In the Indo-Gangetic Plain, home to hundreds of millions of people, satellite data shows the water table dropping at a measurable, documented rate. As Himalayan glaciers retreat and surface rivers carry less reliable water, more communities are turning to wells, accelerating a depletion already stressing one of the most densely populated regions on Earth. These aquifers are not just about agriculture or drinking water in isolation. They are, increasingly, the last safety net for a world where surface water is growing less predictable. The hard truth is this: we have been mining water as though it were oil, but unlike oil, there is no substitute. And unlike oil, human civilization cannot function without it. The science is unambiguous. The satellite data is in. Beneath our feet, a quiet, slow catastrophe is playing out, written in the sinking soil, in the deepening wells, in the ancient water we are burning through without a second thought. The question is no longer whether we are in a global groundwater crisis. The question is whether we will choose to act before the last reserves fall silent forever.